is Bassam Shehbaz and I am mechatronics student. Today I will tell you how to build a SMD from LED flasher. And this is some like a same like a dip components LED flasher, but it has SMD components in it. So I will start from stimulation and circuit. I have used Proteus 8.17 version for the stimulation. This is the 9-volt power supply which I have given to the LED blinker, in which the IC I have used is 555 timer IC, and you can see that why I have used two 555 timer. The reason is that one is for Proteus simulation and one is for PCB design. The reason behind is that the SMD 555 timer have no simulation, and the simulation 555 timer have no PCB SMD PCB design. So that's why I have used two different same 555 timer but in two different footprints, and I have disabled this one stimulation based into the PCB design. This is our two LED circuit, and then we start. There is a capacitor, there are resistors, and there is an LED and an electrolyte capacitor and a ceramic capacitor. The one SMD base, and there we start the simulation. So it's there where you can see that this is a digital logic base and the 0-1 binary logic. When there is 0, this light will flash, and when there is 1, this light will flash. There are blinking in a series like a pattern form. So this is the simulation, complete simulation, and then we will go to the PCB design. So this is the PCB design of our SMD based LED flash. This has a very teeny size, and because there is the biggest component is this 555 timer, and this is an SMD, and this is about the very small size. These are our resistor, this is LEDs, and this is a capacitor, and this is an electrolyte capacitor. The wiring is some like more precise because in which these wires are connected to each other, and they should be very big, very narrow and connected to each other. You can also auto rotate, but in auto rotating there is a problem that we face is our one or more connections are disconnected because of the there is any obstacle in the way to cross that it will make it in the double layer PCB. And in our profession no, in our way how we will build the PCB is only the single way PCB we can build by hands. For the 2 layers we should go on fabrication. So this is the 3D view of our circuit. You can see that there is a timer, resistor, capacitor, and LEDs, and there is a connector for power supply. You can see that its front view, its back view. You can also see its back view like that. The black view is totally empty because there is no components on the back side, and this is a single layer PCB. All the components are on this upper layer, and this is the bill of materials. I have not mentioned the costs. So this is the main components that are used in this. You can see that 555 timer, and these are the things that is used in it. We will take the output from there. This is basically the print. In our process we will take the print layout, but in fabrication we will generate Gerber files. So I will tell you how this is a print layout, and we can do it. Okay, there is our tiny small circuit. You can see that this is our circuit. There we enables the drop silk, and this is our pattern and pairs will displayed. So we can save this file and we can print this and print this on the thermal photo paper to print on the PCB board, single layer PCB board. So next step I will tell you about etching. This pattern is placed on the copper clad sheet of different qualities like FR4, FR3, TP170, 150, and then we paste, and then this goes to the etching process. On etching, we will use the chemicals FeCl3, which is an etching solution or which removes the extra copper clad from the PCB board. Copper clad, extra copper clad is removed, and then circuit that we have pasted on it will remains. And this is our main circuit. This is the board that comes after the pasting of the pasting and cleaning of the PCB board after etching. So this is the pairs, and uh, this is mostly affected and not well etched circuit. I will show you this complete solid circuit which is properly working, and there you can see that there is also shortings, and you can also see that there are many problems in this circuit, like there is shorting, and the circuit most of the time some like circuits are open because of a small cut or small cutting and improper etching like that. You can see that there is no proper pads for there are no proper pads, so the etching is not good of this circuit. I will show you the complete circuit after the soldering. So you can see that this is a complete soldered circuit. A minor shorting was there, which we will correct it by cutting the boards. And this is the soldering. The soldering we have done with solder heat gun, and soldered by the soldering station. This is our ceramic capacitor. This is the place of our electrolyte capacitor that we have leave empty because it has no such needs in DC current. If we are providing 5 volt DC current from a power supply, then there is no need to connect electrolyte capacitor. We are power supplying it from a battery, so we have no need to do this. So this is our circuit, and this is the Proteus. You can see that this is the similar circuit that we have printed and made. You can see that, and this is so. And then I will show you how it's work. We have placed connectors behind it that we have placed there, like there is a connectors, and there is a connector where the positive and negative terminals of the battery connect. We are using 3.7 volt lithium ion battery for it. You can use any battery for it. There is no any specific need of battery for it. You can see that we have connected it by the connectors. You can see that, and our circuit is working, and this is our battery and our connection. You can see in the similar circuit in the Proteus. Our simulation is similar like that. You can see that. So this is the complete video of the SMD LED